Let's practice calculating some measures of center and measures of variability together. All right, so for number one, we have John, Oliver, Isabella, Armand, Ray, and Deacon. They each ran this 400-meter race, or one lap around a track, and the times are recorded in seconds in no particular order. Okay, so let's go ahead and get started by just ordering our data values from least to greatest. So here are all the numbers that we're dealing with. So let's go with the smallest number first. So the smallest number looks like it's going to be 79. So go ahead and write 79 down. I'm going to cross that out. And then I think we have 83 seconds. I think that's going to be the next smallest one. After that, we're going to have 89. That's the third fastest time here. 92 is going to be next, then 99, and then 104. So these are the 6 times recorded for these 6 different runners. So the minimum here, looking for that minimum, is going to be the smallest value. That's going to be 79. So it's going to put 79 down. That is going to be the fastest time. So it's actually the best one here. And then what about for the maximum? Well, the maximum is going to be 104 seconds. So that's going to be the longest someone took here. Now the range, let's see, how do we find the range? Well, the range is just going to be the max minus the min. So I'm going to write that here as going to be the max minus the min. Okay. And so what's the maximum? That's 104. 104 minus 79. 104 minus 79, that is going to be 25. So the range here is going to be 25 seconds between the fastest and slowest runner here. So the fastest time here was 79 seconds and the slowest time was 104 seconds, but the range of all the times was 25 seconds. Moving on to the mode, it doesn't look like any of these times repeated at all, so there's going to be no difference between each of these. So for the mode here, I'm just going to write none because there is no mode in this case because they all just happened one time. Moving on to the median, this is going to separate the top 50% of the times and the slowest 50% of the times, or bottom 50%. So let's go ahead and see if we can find out the median here. So let's figure out where the middle is. So this is the fastest and slowest. Let's take those out. The next fastest, next slowest. And in between here, we have to find what is exactly between 89 and 92 seconds. So to find the median here, we're just going to take 89 and we're going to add 92. That's going to be the sum of the two, and then we're going to divide that by 2. That's going to tell us the average of those 2 times. If we add these 2 together, that's going to be 181. 181 divided by 2 is going to be 90.5. So 90.5 is going to be the median. So half of these runners ran faster than 90.5 seconds, and half of these runners ran slower than 90.5 seconds. All right, so the median, that tells us the top 50% and bottom 50%. Moving on, let's see if we can find the mean. Now this also means the average. So let's see if we can go ahead and find the average. We're gonna take each of their times, 79 plus 83 plus 89 plus 92 plus 99 plus 104. And we're gonna take that all and add them up and then divide by how many people there are, which is gonna be 6. If we add up all the times, we're going to get 546 seconds. If we split those evenly amongst those 6 different runners here, let's see what that's going to be. 546 divided by that 6, that's going to be 91 seconds. So if we took all the times and distributed them evenly, they all ran 91 seconds. But again, some were faster, some were slower. But the average speed between these 6 people was 91 seconds. Alrighty, now for the MAD, or the mean absolute deviation. For this, we're going to be trying to find out on average how far were each of these runners from the average. We're going to start by writing each of these times down in a column. So 79, 83, 89, 92, 99, and 104. Once we have all those times, we want to compare them to the mean. We want to figure out which of these times is above and below the mean. So I'm just going to go ahead and write the mean, or the average, 6 times as well. Once we have the mean, we want to find out each of the deviations from the mean. So 79 minus this 91, that looks like it's going to be negative 12. So this person was 12 seconds faster than the average. 83 minus 91, that's going to be negative 8. This person was 8 seconds faster than average. 89 minus 91 is going to be negative 2. So this person was 2 seconds below average. 92 minus 91 is going to be positive 1. They were 1 second slower than average. 99 minus 91 is 8. This person was 8 seconds slower than average. And 104 minus 91 is going to be 13. So this person was 13 seconds above average here. So while these are the deviations, we can now figure out what the absolute deviations are going to be. And we're just going to go ahead and find the absolute value of each of these. So we're going to have 12, 8, 2, 1, 8, and 13. These are called the absolute deviations. Finally, to find the MAD, we're going to take each of these absolute deviations and we are going to find the mean of them to get the mean absolute deviation. So we're going to take all of these absolute deviations, which is how far each of these runners were from the actual average, and we're going to find the average of these deviations. So what we're going to find is how far on average they are from the average. Adding up each of these deviations, we're going to get a sum of 44 seconds, and that's going to be divided by 6 to find this average. Now, if we do that, we're going to get 7.3 repeaters, so 7.3 repeater seconds, or we can say this is going to be 7 1/3 seconds away from the average. So on average here, we're going to say that each of these runners were 7 1/3 seconds, or 7.3 repeater seconds away from the average. In number 2, we have Cole, Armand, Yadi, Mira, and Angel all participating in a long jump contest, and each of the distances are recorded in feet in no particular order. Okay, so let's go ahead and take our data points here of 12, 12, 10, 10.5, and 14, and see if we can find out some information about them. So writing them from least to greatest to start, just like we did in the last practice problem, 10 feet was going to be the lowest here. We have 10.5 feet as our next one. Then we have 12 and 12. I'm gonna go ahead and cross those out, and then 14. So it looks like we have 5 different people that are participating here. So for the minimum, we can go ahead and say right away that's going to be 10 feet. That was the shortest anybody jumped here. And again, for this one, smaller numbers are not going to be as good. The higher numbers are going to be more impressive. So the maximum here is going to be 14. So someone jumped 14 feet. Now, what's the range? Again, to find the range, that's going to be the maximum number minus the minimum number. So the maximum here is 14, the minimum is 10. 14 minus 10 is 4, so we have a range of 4 feet here. So that's how far the furthest and the least furthest distances are from each other. Moving on to the mode, we are looking for a number that stands out more than the others. Looks like this 12 and 12 happens 2 times, so that definitely stands out a little bit. So we're going to say the mode is going to be 12. Moving on to the median, this is where the halfway point is, so we have to find the middle distance. So we have 1 and 2 on each side, but the median is just going to be this 12 over here, so it's kind of nice, it's right in the middle. That happens to be the mode, but that is just a coincidence, but there are equal numbers of distances on the left and to the right. So half of the jumpers jumped more than 12 and half the jumpers jumped less than 12 feet. Moving on to the mean here, or the average, we have to go ahead and take each of these values and add them up. So 10 plus 10.5 plus 12 plus 12 and plus 14. We're going to add up all the distances that they jumped and then divide by how many people there were, which is 5. Adding up these 5 distances together, we should get a total of 58.5 feet. And if we distribute them evenly amongst each of the 5 jumpers, 58.5 divided by 5, that is going to end up being 11.7 feet. So on average, each of these jumpers altogether jumped 11.7 feet. Now, while that was the average, some of them jumped further and some of them jumped shorter than that distance. We're curious right now for the mean absolute deviation, or the MAD. What was the average distance from this distance of the average of 11.7 feet that each of these jumpers actually jumped? So starting off, let's go ahead and just write our original data values of 10, 10.5, 12, 12, and 14. These were the original distances that each of them jumped. We're curious how far each of them were from the average of 11.7, so let's go ahead and find out some deviations, or how far over or under they were from 11.7 feet, which was the average for all of them. This first person was a little under average, so 10 minus 11.7 is going to be negative 1.7, so they're 1.7 feet below average. Next, we have 10.5 minus 11.7. That is going to be negative as well, negative 1.2, so they were a little under average as well. This next person was above average. 12 minus 11.7 is going to be a positive 0.3, so they were a little bit above average. This next person happened to jump the same, so we can just say 0.3 as well. It's positive if it's above average here. And finally, 14 minus 11.7, that's going to be 2.3, so that's going to be the most above average. If we go ahead and find the absolute deviations now, this is going to be positive 1.7, positive 1.2, and we're going to keep these all as positive as well. These were all the deviations now that we have the positive versions of each of them. Now that we have all the absolute deviations, let's go ahead and find the mean of them to find the mean absolute deviation. So each of these are 1.7, 1.2, 0.3, 0.3, and 2.3. This is all the distances or all the deviations from the average, and let's go ahead and average them to find out on average how far they were from the average. If we add up all these deviations, we're going to get a sum of 5.8 feet here, or we can also say that's going to be 5 4/5. And let's go ahead and divide that by 5. If we do 5.8 divided by that 5, we're going to get 1.16 feet. So on average, each of these jumpers were 1.16 feet away from the average distance of 11.7 feet. All right, so there you have two different practice problems on finding some different measures of center as well as some measures of variation. And if you found the video helpful, please consider giving it a thumbs up. And as always, keep up the great work that you're already doing, and I'll see you in the next one.